Okay. All right, so now we're live. All right. Yep. Okay. All right. So for the Vehicle to Cloud Working Group, I've taken up as design lead. Walt is our community manager, of course. Richard Elberger is one of the stakeholders. Scott Murray is another stakeholder, and Megan Knight is operating as the program manager. This is just a little bit about myself. I work at Amazon as the worldwide tech strategy lead for connected vehicle. And prior to there, I worked at Stellantis. I started there back when it was FCA. One of the things that I did there was to standardize all the vehicle-to-cloud communications using a spec very similar to the one that we're trying to develop here. We also created simulators and message testing capabilities around that protocol spec. It helped to solidify and design the whole architecture and the whole of the program for 2019 and on. So when I joined AGL and I saw that we had a working group for this, I figured we should probably do the same. And so the purpose of this is to produce a prescriptive specification and related assets for the production, the consumption, and orchestration of messages between the vehicle and the cloud. The basis is MQTT, and we're going to use protocol buffers for the schema. But we also want to include recommendations and perhaps even capabilities, which we'll talk about later, around vehicle identity, security, and system architecture. Mainly, we want to produce a set of documentation that defines the best practices recommended for MQTT version 5 for vehicle-to-cloud communication patterns. We can't probably define every single use case, but if we can get to the basic patterns that exist within those use cases, then that's what we want to document. That'll include the message format, very detailed sequence diagrams for the orchestration of those messages, including some of the most common issues that come up in error recovery and handling. We've got a Gradle build configuration for producing both the documentation and the stubs, whether those are Rust or Java or C++. Currently, in the repo, I'm only generating Java and C++. We want example message implementations that we can show users and people that are going to implement vehicle-to-cloud messaging, what that looks like, either in Java or Rust or C++. You can also do Python. I'd like to see some message testing and simulation applications to help people while they're developing. And then I think we'd like to see if we can expose, this actually started as a vehicle identity project, so we'd like to see if we can expose an API through AGL for creating an identity. And it can be as basic as just a salted hash of the VIN, but it'd be nice if there was actually an API in AGL for that purpose. I'd like to have embedded services for the production of the APIs, of the stubs, basically the proto library existing inside AGL. I think it may already, based on some of the things I've heard here today. And also a service just for generating unique IDs for messages. It's something I experienced before. It's better to abstract that out so that you make it apps able to independently create messages without having to have a central application do the messaging, but you need to make sure that you've deconflicted the IDs. I'd also like to see in-vehicle reference applications and services created just to sort of demonstrate what a telecommunications client looks like, what a messaging application looks like, and what a normal service application looks like that consumes and produces protocol buffers. So these are our artifact locations, Confluence. You can read about the scope and everything in Confluence, and we have a repository in Garrett. I just this week put the initial load of assets into Garrett. I just want to talk a little bit about the project structure. The project uses Gradle as the build system, and it has a directory structure that follows source, main, and then CPP for any classes that are generated for C++, Java. There's a doc folder with an images subfolder. All the images that we're using in the documentation will go into this folder. There's a plant UML folder, or PUML. I like to use plant UML to define sequence diagrams, and I'd like to make sure we have very prescriptive sequence diagrams within this project, within the documentation. So we'll do all of that in plant UML. images get generated from that and dumped into the images folder. There's a markdown document called V2C MD. This is actually generated based on a template and the protocol buffers files. And there's the proto messages. There's a proto directory with the subdirectory messages. That's for the service messages. There's also a VSS folder. And that's just basically the VSS spec transformed into protobuf so that it can be consumed by the other messages. There's a README that provides some of the best practices and important concepts around MQTT, and also just describes the project itself. The build.gradle file, and of course, the template for generating the documentation. Yep. So again, the source main, CPP, and Java folders are basically just there for reference. Ideally, you wouldn't be checking these in, but for now, I'm checking in what gets generated. That way people can see it, they understand what we're doing, and later on we can abstract it away so that it's just built on your local system. Doc images will have images like the one we have up here. It's a basic sequence diagram. This one's really simple. Got more complex ones in the project. And that'll just kind of show the basic orchestration of messages. And the plant UML is shown down below here, and that's in the UML folder. This is what the documentation looks like, rendered out of Markdown, if you view it either in a previewer or in GitHub. And it walks you through a description of the message, the orchestration of the message, the MQTT topic design that's recommended. In this case, this is just a header, so there's no topic design. And then it'll list out all the fields. The description is populated by comments that you put in the proto file. If you're familiar with gRPC, you've probably already seen this before. And then the proto messages folder has the proto messages. And this is what it looks like when it's all commented up, right? So all of the things you see in comments get picked up by the protoc document generator, and we'll turn that into the Markdown. You can also do templates for HTML. It's just the Markdown worked really well out of the box, so. Right, and so I've done the bulk of the work so far, but what we're really looking for is to have a conversation, right? And to have people contribute. And we're looking for reviews and edits on what already exists in the repository, new protocol buffer schemas for usage patterns that people know and understand, documentation and other build system enhancements, diagrams and additions to the diagrams that we have in there already, changes as needed, reference implementations for C, Rust, and Python, and that vehicle identity API for AGL, and then aligning the specification message objects to VSS, which I am trying my best to do as I go along, but I can always use help with people keeping me honest. There's also a number of things that I thought might need potential funding, which include that vehicle identity service embedded in Linux, the UUID service, and the embedding of the protobuf libraries if they're not already there. I had also had another line on here that I eliminated because it looks like COVESA is going to handle that, the COVESA.val. I'd really like to see the ability to just call an API and get VSS standard information back instead of having to adjust every application to whatever environment it's in and the CAN standards that it's using. And that was rather quick. I can show you guys what it looks like in my VS Code, but I'd like to open it up for any discussion or questions that people have.
So is Gradle just used for your internal code generation, and then you would build it using the AGL build system?
Yeah, so I started with Gradle because it's easy and I'm familiar with it, right? And the main thing that it's doing is just building the stubs, and it's generating the documentation by calling the protoc D command, right? And that library. So that's it. It's its only real purpose in the project is to generate the documentation and the stubs. So it can be, we can use a different system. We can keep it this way so that people can do it on their local. It's up to you guys.
Drive that from a recipe. I mean, that's the other things built with Gradle and Yocto.
Yeah.
What'd you say, Scott?
You can drive it from Yocto. So,
Oh, okay.
it's just a write a recipe that involves Gradle. So it's workable.
Yeah, and it's keep in mind the Gradle is there mainly for the developer or for us as we change the documentation, as we add new information, it updates it, right? So it goes into the library with a complete set of documentation, and you just have to run that before you check it in, or we put it into a pipeline that runs that whenever it gets checked in, so the documentation's up to date. That's mostly all it's for.
Do you think that the starting point would be the identification service?
I do, yeah. I think that that's the one thing that's not, we can't really handle that easily in the project itself. He asked if the starting point, the next most important thing would be the vehicle identification service, and I think yes. That and the UUID, right? The ability to create a unique ID for the messages would be really important.
Is the UUID service something that is like cloud-based to some degree because you want messages to have the same UUIDs across the fleet?
No, it's got to be to that vehicle, right? You need to be able to publish, well, I suppose across the fleet, yes, but it's not necessarily cloud-based. All you really need is the combination of the vehicle ID and a unique ID for the message, right? So you have to have a service in the vehicle that creates UUIDs, or every application is doing it on its own, or you have to centralize to one application creating and publishing all the messages, right? And I've tried it two ways, one with the centralized message creation and one with the applications doing it themselves. And the applications doing it themselves is a lot better. So that all the TC client has to do is actually establish the connection and make it available, right? And then I can publish on whatever topics I want as an application. Yes?
What are the semantics of these unique IDs? You mentioned it combining the vehicle identity and the message identity. Are these just literally this particular instance of this message has a unique identifier?
The MQTT topics will handle segregating it by vehicle ID or by device ID, right? That's no problem. It's just you can use any UUID service, right? As long as you have the same one for everybody, so you know for sure that the messages are unique. It would be unlikely that two different applications in the same system would create the same UUID, but it could happen.
So an appropriate thing might be UUID 5 in the right mode.
Yeah, exactly. Yeah, it really doesn't matter what framework you use or what service you use, as long as it exists and it's exposed to all the applications, so that you can track whether or not you've actually got a unique ID versus the same ID from two different applications. But, which again, unlikely, right? But it could happen, so it's better to keep it centralized.
So this implies that systems that are using this need a good entropy source.
Yes, yeah, to be 100%, right? But I think I've done a lot of FMEA work, if you're familiar with that process, on this, and the likelihood, one, that it happens, and two, that it causes an actual problem are relatively minimal, but engineers and developers just feel better knowing that it's not going to happen, right? That's why I said that's kind of a lower priority than the actual identity. There's a lot of question marks about identity right now. I talked ad nauseum to our security folks at my company and at some other companies that I talk to. It seems to be that you're either going to go all the way to blockchain for your identity, or a salted hash is sufficient, right? And if you're using the same key as you're using for your certificates, then It should represent no problem for the backend to deserialize that. Now, for but the vehicle identity is different than the device identity, right? In my opinion, your device, the actual TC module that's connecting, that creates, for example, in Amazon, an IoT thing, that's going to be something more like the fingerprint from your certificate that identifies that. The only reason you really need to obscure the vehicle identity, we refer to it as a security issue, but it's really more of a privacy issue, right? You can't send VIN in some parts of the world, including here now, I believe, over plain text across the internet for privacy reasons. So we just want we just need a simple service that will obscure that in a way that's sufficient to keep it from being a privacy issue. So a salted hash is ideal.
Would there be value in trying to link that to, for example, the identity information that an electric vehicle would have for accessing plug to charge and that sort of thing?
Yes. Yeah, absolutely. And I think at that point, that's fine. If you want to link it to the battery itself, then I think you need a different solution. Just because that gets into lifecycle management and auditing and all kinds of compliance issues and regulatory issues, where that's one of the few places that I see blockchain as not being an overkill for the battery itself. But for the VIN, yeah, the salted hash should be fine, and then you can share that with any other system that needs the vehicle's identity, as long as that system can understand it, right?
Yeah, I'm just thinking the plug to charge stuff.
Yeah.
Typically works via a PKI
Yeah.
setup where the vehicle has an identity, has a certificate that's been signed by an authority, usually the OEM, that's authenticated the vehicle.
Yeah, you'll have your vehicle operational certificates tied to that same hash, right? So it'll be tied to the VIN. So then that becomes the identity, and then you can share the certificate as well. Any other questions? And before I wrap up, let me see if I can get it up on the screen here. I'll show you real quick. So this is a diagram I did on the publish and subscribe lifecycle for just standing up a connection, identifying that there's been a subscription to a particular topic, and then preparing to send and receive messages based on that topic, right? And this is what the documentation looks like when it's rendered from the Markdown. This is the basic architecture diagram. We should probably elaborate a little bit more on this as we move along. But I've done that also in Plant UML using C4. And you can see there's a project description, a whole table of contents. So there's that. And then the V2C, when it renders, looks a bit like this. This is not in preview mode, but this is the Markdown. So you can see you got the topic structures and all the information that you need to understand how to consume the API, right? This is the VSS. Where's my... There's a giant table of contents, right? So yeah, there's the message header. We got another one in here for location, but I don't see it. Oh, there we go, precision location. So you can see the topic. Design is a little further down. Oh, it didn't render. Okay, all right, sorry about that. So that's one of the things, is it's not rendering perfectly, and I'll have to keep playing with that, and if anybody is really good with Markdown and templates, then I would love to help on that. But this is the basic repository in, sorry. So here's the location one. You can see the topic information is right here. And then all the different objects. And you can see the comments. It imports the VSS spec so that we can consume the VSS spec as part of the protocol buffer messages. And that's it, unless anybody's got more questions or comments. If you want to contribute or you know someone who would be interested, please feel free to reach out to me or just hit Garrett and check out the repository. All right.